All right, we're in. So, here's our setup. In our single slit, we have a slit of height A, width of 1 micrometer, and 4 meters away, we have a screen. The fringe created by the single slit is 4.8 centimeters. And what if we add a second slit of glass? Well, in total, from the top of the original slit to the bottom of the new slit, it's 250 micrometers, still 4 meters away. And in that space of 4.8 centimeters, we have 7 bright fringes. So knowing this, we want to find the smallest possible refractive index of the glass. How do we find that? Well, let's see if we can figure out some kind of ratio for A first. That's probably our best bet. What we're going to do is put green to start. So, geometrically, what can we tell about A? I drew this pretty bad, but this A should be at the middle of the fringe, and we know that we can make a hypotenuse. It's right angle, right? So now this length is again this length here, so it's 4 meters, and the opposite starts in the middle of the bright fringe. So that's half of 4.8. So if we know the opposite is 4.8 centimeters in half, and we know the adjacent is 4 meters, that gives us an opposite of 2.4 centimeters and an adjacent of 400 centimeters, right? So what can we tell for an opposite and adjacent? Well, that's just the tangent. So we'll do tangent, we'll call this theta here. Tangent theta is equal to opposite 2.4 over adjacent 400. Of course, the units cancel. And that gives us, if we would bother to pull out a calculator before we start the video. .4 divided by 400, that would give us 0.006. So let's save that up here. Tan theta, we'll call it theta S for single. Theta S is equal to 0.006. Okay, well, what does that tell us? Consider the fact that with an extremely, extremely small theta, which is what we're working with here, tangent theta is essentially just theta, and at the same time, sine theta is also basically just theta. So we can set tan theta equal to sine theta. And we know tangent theta is 0.006. We can use that sine theta identity to find some ratio of A, because we're given that sine theta, in this case it's written as sine theta m, is equal to m lambda over A. Okay, well what's m here? Since it's a single slit, m is just 1, so 0.006 is equal to 1, which means lambda over A. If we move A over here so we don't have any denominators, lambda equals 0.006 A. So we have some ratio for A, it's a good starting point. Say that lambda equals 0.006 A. So what can we do with that? Well, if we know there's some ratio that exists for A, we can take that same sine function, equation and put it for double slit, because we have two equations for sine when it comes to this. We have for single slit, sine theta m is equal to m lambda over A, which is this, and for double slit, we have sine theta m is equal to m lambda over d, which is this distance. So let's do it. They're both sine theta, so we can just set them equal to each other. M lambda over A is equal to m lambda over d. Well, what's d? d is the distance from the middles, the centers of each slit here. And then if we know that it's from the center of the slits, that means half the slit on each side is left, right? Well, how big is the slit? We know the slit is A tall, so this is 1/2 of A, 1/2 of A, which means this total distance is D plus 2 times 1/2 A, which is just A, right? So we can use the fact that 250 is equal to D plus A here. But first, let's figure this out. We know M for a single slit is 1. We know M here is the number of, it's given by the bright fringes. So if we start here at the middle, it's 0, 1, 2, 3. We have 3 lambda over D. Let's multiply out A to this side, D to this side, so that we have nothing on the denominator. So we're left with lambda D is equal to 3 lambda A. Divide both sides by lambda to get D equals 3A. We have some kind of ratio here, begin somewhere. D equals 3A. Now, we just talked about the fact that we know the total distance from the top of the original fringe to the bottom of the new glass fringe. That's 250. And we know the total is D plus A. And we just found that D equals 3A, so let's plug that in. Look at that. Now we can solve for A. We get A is equal to 624 to 8 to 5. So A is equal to 62.5, let's put some units, micrometers. Okay, well, if we know this now, we can just plug that back into this original ratio to find 250 equals D plus 62.5 micrometers. Subtract 62.5 from both sides, and what we're left with is D equals 187.5 micrometers. Okay, well, let's remember, earlier we calculated a ratio that isolated the wavelength of A. So now that we know what A is, we can just multiply A with 0.006 to find lambda. So that would be lambda equals 0.006 A, which is 62.5 micrometers, which leaves us with a value lambda is equal to 0.375 micrometers. Great. Now at this point, we pretty much have all the tools we need. So let's try and figure out what that n even is. So let's look at the geometric picture here. We know that it's the same wave, so that tells us, or same light wave, so that tells us delta phi is just 0 because it's the same wave. Additionally, we know that because the middle fringe is a bright fringe, then the two outputs are in phase, so delta big phi is 0 or some multiple of 2 pi. Right? So let's work with that. If we know that delta phi is 2 pi, that would just mean 2 pi is equal to phi 1 minus 2. Okay, well, it's 2 pi minus, 2 pi is equal to k delta x plus, in this case, 0 minus k k prime, delta x plus, again, 0. 2 pi is equal to 2 pi over wavelength delta x minus k prime is 2 pi over lambda prime delta x. Lambda prime is lambda over n, so put this on the denominator. It's 2 pi equals 2 pi over lambda delta x minus, because it's on the denominator, we put it up top, 2 pi n is over lambda delta x. And we get 2 pi is equal to 2 pi, a wavelength of 0.375. Delta x is 1 micrometer, and because it's all in micrometers, don't need to convert anything, minus 2 pi over 0.375 n times 1. And when we multiply that all out, we get 2 pi is equal to, we can take out 2 pi over 0.75 times 1. That would be 2 pi 0.375. You can just ignore the 1 because it's just 1. Or we'll times 1 minus n. Divide this over. So that would just be 0.375 is equal to 1 minus n. And we subtract 1 from both sides, we get negative 0.625 is equal to negative n, which gives us n equals 0.625. This is an issue because n cannot be less than 1. So the easiest jumping point would just to be, go the other way, go negative 2 pi. So let's just add negative here, 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 here. So what we get here is negative 0.375 is equal to 1 minus n. You subtract 1 from both sides, you get negative 1.375 equal to negative n. What we're left with is a more reasonable n equals 1.375 as our final answer.